So we picked problem C, and we're going to be modeling the spread of misinformation on social media. We are team 1096.
My name is Dong.
And I'm Chloe.
We picked this problem because this seemed particularly interesting to us because in light of recent events, we thought this problem was especially reflective of what's going on in our society because as social media has become more popular, it's become more um, convenient for people to maintain information online, and with that, it comes a great risk of being fed misinformation. And we are really interested in how social media platforms can employ different moderation methods in an effort to regulate the spread of misinformation, and how the different moderation techniques can affect how the population receives the misinformation. We have a couple of definition and assumptions. We define there to be five population groups. They start out as uninformed, and they could become informed, misinformed, neutral, and resistant. These five groups will comprise the total population, and the total population holds constant at all times. And each user on the social media platform will belong to one of these population at all times, and they are considered as an active member on the platform. We supposed two methods of moderation for the social media platform. One is warning labels. If a misinformed person creates a post, it will be tagged with the warning that this post contains misinformation. The other is censorship. If a misinformed person attempts to create a post containing misinformation, it will be removed almost immediately by the platform.
So the model that we based our model off of the most is the SIR disease compartment model. So if a disease is spreading throughout a population, its spread can be modeled by the number of people in different populations groups, which include a group of susceptible people, a group of infected people, and a group of recovered people. So in these equations, anytime you have two populations multiplied together, it just represents how much they come into contact. So something like DSDT, where beta is the transmission rate, what the equation is saying is how many people leave the susceptible group based on the transmission rate and the contact between susceptible and infected. And then likewise, you have that group coming into the infectious group in the DIDT equation, and you have a certain population leaving, where gamma represents the recovery rate of infectious people. And you can see that in the recovered group, the DRDT equation, the flux inward of recovered people is described by that same value of gamma times I. So we decided to model the spread of misinformation kind of like a disease, and our model borrows a lot of these concepts. So our exact model has 5 compartments. For some kind of initial condition, we said that most people end up starting out in the uninformed group. You need at least one person in the informed and misinformed group each to really get things going. And then we also assumed that if a person is part of the informed or misinformed group, they actively start trying to persuade people to join their group. If a person becomes part of the neutral group, it means that they've been exposed to the information or misinformation and don't care to spread it. So they're not actively spreading misinformation or information for that matter. The resistant group is our 5th compartment that describes people who have had moderation used on them in the misinformed group, and then they start using things like code words or other websites to continue to believe and talk about this misinformation. And at that point, since they either leave the platform or start using code words, you can't really moderate them anymore. So in a sense, they're resistant to the moderation, and but they're not really spreading information on the platform anymore. So our system of differential equations kind of mimic or repeat the style found from the SIR model. So the change in the uninformed population with respect to time has a group leaving, where alpha is how the informed people can influence the uninformed group, and the contact between the informed and uninformed group is multiplied by alpha. The negative means that they're leaving. Likewise, beta is the rate at which misinformed people influence the uninformed people. So it's that rate times the interaction between the misinformed and uninformed populations. We said that we associated two rates with warning labels. One is the rate at which informed people can influence misinformed people to join the informed population with warning labels. And delta is the rate at which misinformed people join the resistant population because of warning labels. Likewise, for censorship, we have the same thing going on, where eta is the rate at which informed people can influence misinformed people with censorship, and theta is the rate at which misinformed people join the resistant group because of censorship. We also thought that there should be a rate at which uninformed people interacting with the informed and misinformed groups decide to become neutral. So we figured that the rate would be the same for each group, and that it would be multiplied by U, and it should be I plus M. I mistyped that.
We have some initial conditions for our model. We assume that the total population contains 100 people, and 98 of them will start out as uninformed, and with 1 in misinformed and 1 in informed. The rates alpha and beta will vary depending on different moderation methods, and it will vary depending on whichever group we decide to be more influential. Our assumption is that the warning label method would cause some people to become informed, but ultimately lead to a small group of people becoming resistant. And on the other hand, the censorship would cause fewer people to become informed, and more people would dislike the more extreme method of moderation, and they will become resistant. And for uninformed people, we decided that the rate they interact with informed and misinformed people leaving to join the neutral group would be constant. For warning labels, it is a more mild method of moderation, and we decided that the rates of influences should be lower compared to other moderation methods. So these are our initial conditions on the left. These are our rates of influence on the left, and this is on the right is our graph for how the population turned out. There are about half of them becoming neutral, 35% became informed, and about 15% became resistant. For censorship, we turned up most of the rates, and we especially decided that it would encourage the majority of misinformed people to join the resistant group, so that theta is 0.8, which is very high. It turned out that resistant population has about the same amount of people as the informed population, at about 35%, and the rest of 30% is comprised of neutral population. And we decided that some platforms might have a mixture of those two moderation method, so that the rates of influence would be somewhere in the middle. And we saw that there were less neutral population from from the warning labels method, and there are more informed people, but there were also a fairly more amount of resistant group.
So here are the interpretations and conclusions from what we modeled. Because 98% of the population starts out in the uninformed group, the rates of alpha and beta are most critical to determine how the population will change. We found that the more informed and misinformed people can grab from the start before they start moving to neutral groups was really important, and that's why. So more mild moderation methods like warning labels will leave more people as neutral, but more informed people than resistant people. And we figured that this happens because just from the diagram, there are more pathways to becoming informed rather than resistant. So more extreme forms of moderation like censorship will prompt people to become resistant. So about the same amount of people will become informed, and there are fewer neutral people. A mixture of methods will have about the same amount of informed and neutral people and fewer resistant people. And more studies can be done to measure exactly how moderation methods can affect the influence rates. Since our model has more ways for people to become informed rather than resistant, we expect higher amounts of people to become informed in the end. Some improvements for our model that could be done in the future. So our model doesn't consider how the influence rates can change with respect to time. So, for example, we reasoned that realistically, if more censorship was used, the informed group might actually lose their influence over uninformed people. And this is because there's just a general negative reaction to the use of censorship in media. If we wanted to increase our accuracy about the rates at which the populations change, we'd want to analyze real data and adjust accordingly. And we figured that by adding more compartments to this model, it might help to build a more realistic scenario. And for like one example of that is maybe the misinformed group can be broken down into people who are aware that it's misinformation but spread it anyway, and then people who actually believe in it and choose to spread it because they think it's true. If someone knows it's wrong but still wants to spread it deliberately, they're probably being strategic about it and know how to spread it better. So things like that might increase how realistic the model is in the end. And these are our sources. Thank you.
Thank you.